keeping in tune with all of the stuff that we've learned so far, you've noticed that radians is what rules, right? Degrees is just a wonderful way of doing things, and it's a common way of describing an angle, but radians is where it's at, right? Take a look at this question. What if I want to find the area of a sector? What do I mean by sector? A portion of the circle. Well, guess what it's bounded by? It's bounded by, of course, these 2 points based on the angle. And I wonder what the angle is going to be in. Yep, radians. So here's something that's interesting. If we set up a proportion of the sector, the area of the sector over the entire area of the circle, look what I've got. The area of the sector over the entire area of the circle, area of a circle we know is pi r squared. And if we bound that the same way that we did everything else, and we said, okay, what is the angle? Well, that angle here is, of course, theta. What is the angle all the way around? Well, you know it is 360, but for one revolution, I'm going to just say it's 2 pi because I want to keep everything in radians, right? Watch what happens. We can take this guy now, do a little cross multiplication magic, and look what we got. We've got theta times pi r squared right there. Oh my, let's get rid of a few things like the pi's. And look what we have. We have theta r squared over 2, or better yet, 1/2 theta r squared. And that theta, of course, has to be in, you got it, radians. There's the radians formula for area of a portion of a circle. Okay, so how do I do it? Well, guess what? Right here. Example 8. Let's go. First things first. It says in this particular thing that what is the area to the nearest tenth of a centimeter of a sector subtended by an arc of 70 degrees and a radius of 5 centimeters? What? What? Simple. Draw a circle. Start here. Make your 70 degrees. My 70 degrees up to about, let's say, here. Okay? I don't know if that's 70 degrees, but that's close enough. So what I want to do is I want to find this sector area. Okay, first things first, 70 degrees, not in radians. So I got to change it. 70 degrees, convert it. Okay, degrees on the bottom, radians on the top, a little dimensional analysis, pi radians, 180 degrees. Oh my goodness, which means that and that cancel, means the 0 and 0 cancel. I have 7 pi over 18 radians. Okay, because our degrees, of course, cancel. Right? Okay, what does that mean? Remember the formula. The formula was 1/2 r squared times theta. Well, there's your theta, there's your radians. 1/2 your radius, of course, being 5. 5 squared now times 7 pi over 18. Oh, that looks like a mess, doesn't it? Not really. Throw it in your calculator. Watch. Real simple. You know that this was, okay, 1/2, 5 squared, 7 pi over 18. Okay, 1/2 radius squared, which was 5 squared. Okay, 5 squared. Okay, and last but not least, 7 pi over 18. Okay. Bracket, fraction, 7 pi over 18. Wow, it looks exactly like what I have written here, doesn't it? Beautiful. All right, punch it. Bunk. I get 15.27. That's what I get for punching it twice. 15.27. All right, so 15.27 what? Now it says nearest tenth. So 15.3, but 15.3, what units though? Remember, this is area and you're in centimeters. Ah, okay. So this has got to be centimeters what? Centimeters squared. Aha, because it is an area, right?